Okay, so here is a tank question and work done in filling the tank. So they show us this trapezoidal cross section of this tank, and you can see it right up here. There's a three-dimensional view. It shows that the tank is 3 feet deep. Um, so what I'm going to do is kind of redraw it. I want to look at the front of the tank. So this part, because I'm going to need that to get the equation of these lines. So first of all, that's 1 comma 0. According to this diagram, this is 2 across, so this would be 2 comma, how high is the tank? Oh, it says 3 here, so 2 comma 3. And we are going to assume the engine is 3 feet above the top of the fuel tank. So the engine is up here on this level. And this would be, since this is 3, this would be y equals 6. So we're going to pump the full tank to the level of the engine. So here's a representative slice, and we're going to pump this to the engine here. Now, a lot of times we've been looking at circular tanks, so this would be a little cylinder, but if you look at this tank, it's going to be like a rectangular prism, like a box. So when I get the volume of this to get the weight, it's going to be length times width times height. So first of all, I'm going to need, the height of this is delta y as always. The length depends on this graph. Or width, I guess we can call it. The length, or this length, is always 3. So the volume of this box here would be length times width times height. The width is this. So that's going to depend on this graph. So this graph is a line. It's y minus y1. I'm going to look at this graph right here. Y minus y1 is y minus 0 equals the slope. This is definitely up 3 over 1. So the slope is 3 times x minus x1, x minus 1. We're going to want to solve this for x. So x is y over 3 plus 1. So that's the length of this. That will be the right x right here, which is y over 3 plus 1, minus the left x, which is 0. So y over 3 plus 1. If I multiply this by the weight density of this fuel, which is 53.1, I have the force. So hopefully that's not too hard to read, too messy. One thing I'm going to do is I'm going to multiply that 3 through, because it just looks like it's going to simplify things a little bit. So y plus 3 times delta y times 53.1. Now we have to figure out the distance we are pumping this. So we got a force. We need to multiply by this distance right here to get it to be a work. So work would be this force times the distance. Well, this distance is this y minus this y. Y equals 6 is up top, and then down bottom, that's just the however far we are on the y-axis, so it's y. So to measure this distance, it'd be the top 6 minus the bottom y. So there we go. So the total work is the integral of this. So we have 53.1. We have the y plus 3 here times the 6 minus y here. We have this delta y, which is dy. And now we just have to figure out the limits. Well, since we're doing the entire tank, we're starting from down here at y equals 0 and emptying the whole thing, so to here, y equals 3. So we're going to go from y equals 0 to y equals 3. And that should do it. So I'm going to calculate this. It's taking a while. I wasn't prepared here. Let me get it in the right function mode here. And now I'm going to type this in. So we have 53.1 times y plus 3 times 6 minus y. So I have it typed in the calculator. I'm going to hit graph. And I'm going to do this from 0 to 3. So second calc integral from 0 to 3. And it gives me the total work is 3,106.35. 3106.35. And I think this was in foot pounds. Yes. So foot pounds. So that's how you calculate the work done in emptying a tank.